We are still discussing conditional probability and we are still on the basics, and today we are going to be looking at false positive and false negative. Now, what is false positive? False positive is when a test yields a positive result, meanwhile the actual outcome is negative. False negative is when a test yields a negative result, but the actual outcome is positive. I can give you an example. Let's say a patient is being diagnosed for cancer, and the doctor diagnoses the patient and determines that the test result yields that the patient is positive, that is, there is cancer cells, but eventually it was found out that the patient actually does not have cancer. So this is actually example of false positive, when the test is telling you there is something, but actually there is not. This is false positive. But when the test is telling you there is not, and actually there is, this is false negative, and this can be dangerous. So assuming a patient have cancer and have maybe 1 year to live, and the doctor carries out diagnosis and comes out with a negative test result that there is no cancer cells or there is no cancer, and fails to administer cancer treatment, you find out that maybe after 1 year the patient dies of cancer. So in this case, this is false negative. And false positive and false negative is something that is very important in data science, in machine learning, and in statistics and mathematics. And this is what we want to discuss. And it's something that has to be avoided as much as possible. So let's talk about it in this case, and let's see how we can make a few calculations about it. So coming back to the discussion on ground, let me take a pen. So if we go back to this table, you see that at this point, if we have T minus, it means that the patient's result is negative of the disease. And at this point, we have T minus under D plus, actually where the result is negative, but the disease is there. Let's formalize this. I remember that before now I gave you a little assignment. I told you to calculate conditional probability. I told you to calculate conditional probability of T plus given D minus. So this is conditional probability of a false positive happening. Let's calculate it and see and make sure that this probability is very, very low, and it should be very low. Can you set up the formula? So it goes this way. Is the probability of T plus and D minus divided by the unconditional probability of D minus. From the table, what do we have? We have, let's see. So probability of T plus intersection D minus, we have T plus intersection D minus 0.110 all over the unconditional probability of D minus is 0.684. So I need to take a calculator to solve this. Let's say look for calc. Okay, so let's solve it and see what value it is. So 0.110 divided by 0.684, it gives us 0.161. So this gives us 0.161, 0.161, okay? So it means that, which is equivalent to 16.1%. So it means that there is 16.1% chance that the test is going to result in a positive result. Meanwhile, the disease is not there. This may not be too much of a problem because you have the situation that the disease is not there, but you are administering the drugs for the disease. That may not be a problem, as at least the disease is not there and everybody is safe. Let's now calculate the probability, the conditional probability that the disease is there, that the disease is there, or let's calculate the conditional probability that the test result is negative, given that the disease is there. So let's say probability that the test result is negative, but the disease is there, is going to be probability that the test result is negative and the disease is there, I'm making a mistake, divided by the conditional probability that the disease is there. So let's calculate to make sure that this actually has to be very, very, very minimal. Because if there is this thing happening every time when the disease is there, but the doctors find a negative result and they fail to administer the treatment, the patient might actually lose his life, and that is a serious problem. So let's calculate this and check and make sure that it's actually very minimal. So probability of T minus intersection D plus, T minus intersection D plus, that is this, which is 18. Okay, sorry, we are using the other one, which is 0.132 T minus on the D plus, divided by the unconditional probability of D plus, which is 0.316. So let's take our calculator again and see what we have. Alright, so we have 0.132 divided by 0.316. This is going to give us 0.418. So 0.418. So this is actually a problem because we have a 41.8% chance that the disease is there. Meanwhile, the doctors are getting a negative result, and this is a problem that has to be avoided. And that is why I'm going to show you another topic to read. I actually made this up. Yes, I wrote this, basics of decision theory. How does decision theory work? How does medical diagnosis work? So go ahead to read this decision theory, basics of decision theory. It actually clarifies everything very easily. It actually works. In this case, it gives an example of cancer treatment. And I recommend you read it. So we've calculated probability of false positive, probability of false negative, and this is how we come to the end of the basics of conditional probability. So we've covered the basics of conditional probability. The next post we are going to be discussed is, I think it should be the law of total. Okay, let's see, conditional probability multiplication law. So that is what we are going to discuss in the next article. I'd like to thank you for viewing and also want to remind you to subscribe to my channel if you've not subscribed, and we'll see you in the next lesson.